Hi, my name is Greg Martin. By the end of this video, you're going to know how to describe, summarize, and visualize your data. You're going to be able to produce the right tables, plots, and graphs for different kinds of variables. And believe me, this is the first step to good statistical analysis. So let's get stuck in. In a typical data set, we've got something like a spreadsheet. And in this spreadsheet, we've got columns, and our columns are our variables. And in this case, we've got 5 variables, and our rows contain our observations. Now, and we've got 4 observations here. What do I mean by observations? Let's talk about someone called James. James has got certain characteristics that we're interested in. He's a 27-year-old male. He weighs 75.1 kilograms. He's been categorized as short. And together, we call all of this information about James an observation. And we store that information as data under the appropriate column headings or variable headings. And of course, we can add as many observations as we want, and this is what makes up our data set. Now, the most common 2 types of data that we work with are categorical and numeric data. Let's take a look at a categorical variable like gender. Each person or each observation in our data set can be categorized either as male or female. And you can think of these categories as buckets, into which the values from any other variable can be placed and then compared. So we could compare the average weight or the average age of men and women in this group, for example. Now let's take a look at a slightly different kind of categorical variable. In this case, I want to take a look at height, right? And this is what we call an ordinal categorical variable. Now in the case of height, again, we've got categories or buckets. And of course, again, we can categorize the observations in our data set. But in this case, the order matters, right? So it's short, medium, tall. That matters. And that's why we call it an ordinal categorical variable. There's a natural order to the categories. Now let's talk about the 2 types of numeric variables. These are numbers. They fall by definition on a number line, but they can fall on that number line in 2 different ways. They can be discrete or continuous. Right, let's talk about age. Age is typically given as a discrete variable. In other words, each observation falls definitively on a value on the integer number line, 32, 33, 34, etc. Weight, by contrast, falls on any number, including fractions between 2 integers, right? So in this example, Barra is 98.3 kilograms. But now we want to talk about how it is that we're going to describe all of these variables. A trick to understanding how your numeric variable values are distributed along the number line is to imagine them actually sitting on the number line. Where there is more than one observation for a particular number, they get stacked upon each other. And as you can see, this turns into an interesting shape, which we call a distribution. And this is an interesting idea that we use again and again and again in statistics. So here we've got a data set, and I've shown the distribution of the numeric variables by representing each observation as a ball. Let's take a look at the most useful ways that we can describe this data. Firstly, the minimum and the maximum values, and these also happen to be the parameters for the range. And the range tells us a little bit about the distribution or the spread of the data. And if we divide all of our observations into 4 equal groups, each of those groups will of course contain a quarter of all the observations, and we call the 2 middle quarters the interquartile range. And this again is telling us something about how the data is spread out. Now the next 3 are interesting because they're trying to tell us something about the middle of the data. Welcome to the course on basic statistics.
Sit back, enjoy, buckle up, let's do this.
First of all, we've got the mean. The mean is the average. Then we've got the median, and the median is the value that splits all of the data into 2 equal groups. And then of course we've got the mode, which is the most common value. Now where the distribution or the shape of this data is pretty symmetrical, as in this case, then those 3 values will be pretty much the same. However, if the distribution of values has got a long tail to the one side, right, the left side in this case, and we say this is left skewed, then suddenly the mean or the average is disproportionately affected by the outliers and these extreme values. And similarly, if you have a right skewed distribution, and remember the tail is to the right, so we say that it's right skewed, the mean is way too far to the right, so it's not a good measure of centrality. Clearly, when the distribution is skewed, The median is a more robust measure of centrality. And finally, the standard deviation tells us about the average distance from the mean. In other words, how spread out the data is. So if this is the mean, then one standard deviation on either side of that is the average distance of the observations from the mean. And it turns out that if your data is normally distributed like this is, then about 68% of all of the observations will occur within one standard deviation on either side of the mean. And about 95% will be within two standard deviations. So what have we got? We've got the mean, the median, and the mode. They're telling us about centrality, about the middle. Where's the middle of this data? And then we've got the range, the interquartile range, and the standard deviation, and they're telling us about the spread and how spread out this data is. Now, we've got terminology. We've also got terminology that tells us about the shape of the distribution. We've already talked about the idea of the distribution being symmetrical or skewed to the left or the right. If there's one peak, like in this particular data, we might say that this is unimodal. If there were two peaks, we might say that it's bimodal. And there are other distributions that we can talk about, but the best way to get a sense of how to describe the shape of the distribution is to visualize the data. So let's get into that for a bit. A short pause to this video to say a big thank you to Springer Nature. Now, this video has been sponsored by Springer Nature. Springer Nature did not create the video. They had no editorial involvement with the video. They take no responsibility for the video. That's the stuff that I'm obliged to contractually say to you. There's a few things about Springer Nature that I want to say to you that I don't have to say, but I want to say anyway. Springer Nature publish some of the most influential scientific journals in the world today. Something that we're not cognizant of in our day-to-day lives is that the science and technology that underpins the lives that we live at the moment, so much of the lives that we live, the medicines that we take, the fact that things work the way they do, so much of the quality of science that we depend on is underpinned by high quality scientific publication. It's only of the quality that it is because of publishing companies like Springer Nature that insist on scientific integrity in terms of what they publish. Springer Nature are a real force for good in this world, and I feel I'm really grateful and really honored that they're prepared to support my work and this YouTube channel. So thank you very much. And now on with the video. Now, the first way that we can visualize the distribution of a numeric data set is by imagining buckets that represent different intervals along the x-axis. And you can choose how big the buckets are. Let's say in this case, we're going from 0 to 10, 10 to 20, 20 to 30, etc. And then by counting up how many observations fall into each of those buckets, we can create what we call a histogram. Next, let's talk about box plots, right? Remember when we were describing our data, we divided our data into 4 quarters, right? And the middle 2 quarters were described as the interquartile range. Well, we can draw a box that represents the interquartile range with a line in the middle representing the median. So voila, and we've got a box plot. So with our box plot, the interquartile range is in the box itself, and that'll have 50% of the data. The median, which is the value that splits all of the data into 2 separate groups, that's represented by the middle line in the middle of the box. The whiskers are extended out to 1.5 times the interquartile range, and any values outside of that range, we call them outliers. Now let's take a look at a categorical variable like height. Each observation, so James, Barra, Sarah, etc., has been categorized as either short, medium height, or tall, right? And we can summarize this categorical variable by counting up the number of observations that land up in each category. So, for example, we could say that there have been 4 people that have been categorized as short. We can say that there are 2 that are medium height, 2 that are tall, and altogether we know that there are 8 altogether. Now, if you want to know what proportion of the total are short, right, we call that the relative frequency. Then, of course, what you do is you divide the number of short people by the total, and boom shakalaka, you've got 0.5, which is a half. And if you want to know what the percentage is, well, you simply multiply by 100. And boom. And there you go. We've got the percentage for each category. If we want to visualize this data, of course, we can use a bar chart where the height of the bar is either the actual number of observations or the relative frequency or the percentage. An alternative is to use the pie chart. There are different reasons for using different graphs at different times, and I'm not going to get into that today. Now let's think about 2 categorical variables, right? Gender and height. The first thing we do is we create a two-way frequency table. Two ways because we've got both of our variables involved now, and we use one in the columns and one in the rows. And again, we can calculate the relative frequency, or the percentage, which can be represented in brackets next to the value. So previously we had it in a separate column. Now we've got it in the brackets next to the value itself. And you can do that percentage by rows or by columns, right? So in this case, I've done it by columns. So I've calculated what percentage each cell is relative to the column total for the column that it's in. So for example, in the male column, 3 men are short. That's 3 out of a total of 5 men altogether. So 60% of the men are short, and so on. And I'm going to show you two ways that you can visualize this data. So firstly, you can have a stacked bar chart where the height of each column is determined by the actual number of observations. Or you can stack them by percentage so that each column towers up to 100%, making it much easier to visually compare proportions. If you have two numeric variables, how are you going to visually represent them? Well, one thing you can do is you can create a scatter plot. So a scatter plot is where each point corresponds to the x and the y coordinates of a given observation, or in this case, a person. So, for example, we've got Sarah, she's 34 years of age, and she weighs 63.5 kilograms. So this is her point on the scatter plot. And of course, you can add a trend line. And then remember, by convention, we usually plot the independent variable on the x-axis and the dependent variable on the y-axis. And what do I mean by that? Let me just explain that to you, because it's kind of quite important. It's all about the direction of causation. And so what do I mean by that? Well, in this case, we think that a change in age might affect weight. In other words, as you get older, you might gain weight. We don't think that a change in your weight affects or has any causative impact on your age. Weight, by contrast, might be dependent on age or might be affected by age. There might be some sort of causative relationship between what your age is and what your weight is. And so weight is a dependent variable, and typically, by convention, we put those onto your y-axis. Now things are about to get interesting. How would we plot two numerics and one categorical variable? Well, first of all, just imagine plotting your two numeric variables one against each other on a scatter plot in the way that we've described already. Now, for each of the points on the scatter plot, we use the categorical variable to assign them into a different group, or a different, in this case, maybe a different color. Okay, then of course we can also draw a trend line independently through each of those categories, one for males and one for females, and voila, we can see two graphs superimposed upon one another, and we can see the difference between the genders with respect to the relationship between age and weight. Now let's talk about two categorical and one numeric variable. First of all, let's consider just the numeric variable by itself, in this case weight. And how would we plot that? Well, we'd create perhaps a box plot. Now we want to use just one of the categorical variables, let's start with gender, to disaggregate that data and redraw our box plot. What we've got here is we've got the same weight data being used to draw this plot. Those observations that have been categorized as female have been used to draw the pink plot. And of course, we want to represent more than one categorical variable. We want to include height here. So what do? We disaggregate the data once again by height. So now we've got weight, and it's plotted, but the plot has been disaggregated by first gender and then height. And so we can see the difference in weight between males and females in tall people, and the difference in weight between men and women for medium height people. And of course we can see a difference amongst short people, and the difference there seems to be most pronounced. If you want to learn more about statistical analysis and other research methods, then go to learnmore365.com. I hope you enjoyed the video. Hit subscribe if you haven't before. Hit the bell notification if you want to get alerts to future videos. Also,